Hey chemists, this is part two of the laboratory we started on Friday, analysis of hydrogen peroxide. The, the focus of part two is to determine the percent of hydrogen peroxide in a brand of peroxide that you could buy at the grocery store. On the label, it says 3%, but your job is to determine if that is actually accurate, and this laboratory will allow you to calculate that. We are going to take a look at some calculations that will hopefully help you, and also review it so that you can write a procedure for Monday, because ultimately with your internal assessments you're going to have to write your own procedures. So now is as good a time as any to start getting some practice with that, and hopefully this video will help guide you for Monday. If it's not perfect, it doesn't matter. It's the process of beginning to feel comfortable doing that. We're going to your potassium permanganate is now standardized, and you are going to take some hydrogen peroxide and substitute that for this part two. You're not going to be using your ferrous ammonium sulfate anymore, but you're going to use the peroxide that will be available in the laboratory. It'll look like I bought it from CVS, and the fact of the matter is I did. Potassium permanganate will still be the oxidizing agent, and what happens here is that hydrogen peroxide is the oxygen in potassium, the oxygen in hydrogen peroxide is a -1, and oxygen, all elements in their natural states have oxidation numbers of 0, which we will again learn about. This is the balanced half reaction. The balanced half reaction for the reduction of hydrogen peroxide to oxygen. So you'll probably see some bubbles of oxygen being formed when you do this. Hydrogen ions are present. We've also got the sulfuric acid. Everything stays the same in the lab, except you're not using the ferrous ammonium sulfate. You're using the hydrogen peroxide and then 2 electrons. Once again, I have my little box to guide us step by step. Okay, I don't expect you to be able to do this, so I have given you, this represents the balanced equation, the balanced net ionic oxidation reduction reaction for hydrogen peroxide with permanganate. The key feature for you here is that it is a 2:5 ratio. For every 5 moles of this, 2 moles are consumed, or if you want to think it the other way, 2:5 between permanganate and the hydrogen peroxide. So that's your go-to equation. All right. So it's nice to have a sense, an approximate idea of how much potassium permanganate solution you're actually going to need to carry out this reaction. If you need 500 milliliters, you're in trouble. So what we're going to do here is a back calculation to give ourselves a sense of approximately the volume, so that when we approach the titration, we have a ballpark sense of what volume we need to be a little bit careful of as we approach, perhaps slow down the titration. So the question is, calculate the approximate volume of potassium permanganate needed to react with 1 milliliter of hydrogen peroxide. So if you measure out 1 milliliter and you put it into the flask, you add the same amount of water, you add the same amount of sulfuric acid, and then you go ahead and you titrate. What's the approximate volume? If we read on the label that, or we assume that the label is correct, it says 3%. Right? So keeps flipping up. Sorry about that, everybody. Hydrogen peroxide is 3%. So they say. A percent, we all know, we should know from our 5th grade math, is a percent is a part over a total. So the hydrogen peroxide, the 3% means 3 grams of hydrogen peroxide in 100 grams of water. That doesn't really help us because we need to be in milliliters, right? So the density of hydrogen peroxide is approximately, let me get rid of, I don't know what that thing is right there, guys. Sorry about that. The density of hydrogen peroxide is approximately 1 gram per milliliter, which means that if the density is 1 gram per milliliter, that means 100 grams is going to be 100 milliliters. So the density of H2O2, 3%, 3 grams per 100 milliliter. Does everybody see that? If the density is 1 gram per mil, then 100 grams would be 100 mils. And since percent is 3 grams of hydrogen peroxide per 100 grams of water, because that's the definition of percent, then I can rewrite 3 grams of hydrogen peroxide per 100 milliliters. If I want to look at just 1 milliliter of hydrogen peroxide, then I'm going to move the decimal place over 2 places in the denominator, 2 places in the numerator. Basically, I'm dividing numerator by 100 and denominator by 100. Then, from this original statement, I am assuming, at least for an approximate calculation, that in every milliliter of hydrogen peroxide, there's 0.03 grams of hydrogen peroxide. Okay, I'm going to get rid of that so it stops flipping around. Take a look at this. I'm going to do something else here, guys. Hang on just a sec. Bring that down here. Otherwise, and then, okay, I'm going to make the box a little smaller here. Okay. All right, there we go. Okay. So here's my 0.03. This is an assumption based on that. So you'll take again, this is getting a sense of what the volume of your permanganate will be. 0.03 grams of H2O2. I divide it by its molecular mass. 1 sig fig there, 3 sig figs there. I'm going to take a little scientific license and give myself 2 significant figures to work with. That gives me 8.8 times 10 to the negative 4 moles of hydrogen peroxide. Recall that it's 2 to 5. So for every 2 permanganates, 5 hydrogen peroxides are consumed, which leads me to a value of 3.5 times 10 to the negative 4th moles of potassium permanganate. Okay. Now, you can either use your standardized potassium permanganate concentration, or because this is just an approximate calculation, you can stick with the 0.02. It doesn't matter. I'm going to stay with the 0.02 because I'm looking for approximate, and just math-wise, it's a little bit easier. I remind myself that the molarity is the number of moles over the volume. I know this, or this is your concentration of your potassium permanganate. You can substitute your standardized value if you want, equal the moles of potassium permanganate that I have calculated based on the fact that there's 0.03 grams in a milliliter of hydrogen peroxide. And I've got this calculation right here. So concentration equals moles. Volume is the unknown. If I rearrange and calculate, I get volume. Let me write that for you here. Volume is going to be 3.5 times 10 to the negative fourth moles over 0.02 mole per liter. I'm going to get liters, and then I can multiply by 1,000. And what I arrive at, and you should convince yourself that you can follow these calculations, I get 17.6 milliliters of potassium permanganate. That is the approximate volume that you should expect to use based on 1 milliliter of hydrogen peroxide. Now you may say to yourself, okay, 1 milliliter of 1 milliliter of hydrogen peroxide isn't very much, and I would like to have a little bit more hydrogen peroxide in my flask just so I have a larger volume, or not. If you decide to use 2 milliliters of hydrogen peroxide, then you would double that and you would get a value around 35. Sticking with the 1 milliliter, you're using less volume, and I would suggest that you're going to use a pipette. You'll use a volumetric pipette. So using 1 milliliter is fine. If you want to use 2 milliliters, you will have to base that on how much potassium permanganate you have available and how much is still remaining from the amount I made. If we run out, then you have to do the whole laboratory over again and restandardize. So we should probably go with one milliliter and see what happens. The important thing to remember, finally, is that you're going to keep all your reagents the same for part 2. Substitute the 1 ml of 3% H2O2. Okay, we are told by the manufacturer that it's 3%. You're going to actually determine if that's correct. Okay, that's what this lab is about. You'll still use your whatever volume of water you used in part A, whatever volume of your sulfuric acid you used in part A. The only difference is this gets substituted for this. So go ahead and work the back calculation so you have a sense of this for yourselves, and then you will need to. Okay, so this all means that you will write a procedure for part 2. Confer with your your partner. Okay, you don't want to have Please don't one person write the lab and the other person comes along for the ride. I'm fine with you. I want you to write your own procedure. Okay, I want everybody's to be different because this is important for you to begin feeling comfortable with doing this. You can confer with your right, but each procedure must be individual. That's your assignment for Monday. But feel free to talk to your partner and over the phone or however you want to communicate. And I will see you on Monday for lab. I hope that's helpful. Okay, bye for now and see you in the next video. And as soon as I can figure out how to get out of here, which is always complicated.